Welcome to reality. 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 Welcome to reality.
Hello and welcome.
Hello, Nope.
Hello, everybody. Welcome to reality, where your host, TechTranslate, and myself, NOPEGENX, tackle the flat Earth misinformation spreading through social media. Now, I generally keep an eye on YouTube and Facebook, while TechTranslate is focused on X. So, in each episode, we'll be looking at one subject and going through its reality with you. Sound good? Let's go see who's here.
Yeah, okay.
So, we have some lovely people already waiting. I think we've got Zerzu in there. Hiya. Well done. Thanks very much for coming. I have the lovely Nikoti joining us to keep an eye on things, and hopefully people will trickle in as we carry on. So, so what is today's activity there?
Yeah, I heard you want to know something about the horizon. Is it possible?
Well, this is
What
it.
it is?
Now,
Yeah.
as much for me as anyone else. Now, I'm not the most educated person, and I'm the first to admit it. But I've got a lot of common sense, and I do follow along with a lot of things, and I realise that flat Earth is completely stupid. Where TechTranslate is actually quite knowledgeable. We got together through X.
A little bit.
Little bit knowledgeable, much more knowledgeable than me anyway. So
average. Yeah.
averagely knowledgeable, but way better
Okay.
than any flurf I've ever met. So well done to you there. So what we're going to do is go through the horizon and actually give it a little bit of a going through and a little bit of understanding, and hopefully you'll enjoy it. So let's have a quick look. Now, one of the things I know about the horizon is it's literally the line at which the Earth's surface and the sky appear to meet, as defined by the dictionary. Flirts, on the other hand, seem to think that it means it's horizontal. Now, obviously, it says it's parallel to the plane, and that's where they get their flat from, but it's plane of the horizon, so they kind of make all these silly.
Exactly. They go very often with words. Now, when they read something like plane, they say, see, evidence, the world is flat. No, this is, they very fast jump to such a conclusion. Yeah.
So this is what you actually put up on X, and this is one of the first sort of things that I noticed about your slides, is they're very intuitive, very easy to understand, and hold a lot of information. So
the main purpose was why I wrote this. I posted before the picture on the right with the wind farm, and I got very strange responses from them. They said, where does it curve? At which coordinate does it curve? No? So they had the understanding basically that curvature mean it curves at a certain point. No? And I thought, okay, I think I have to explain this. And this is why I made the slide. And so a sphere curves continuously, and the horizon is basically the point where things are no longer in your line of sight. And you perfectly see this with the windmills of the wind farm, where you see also some are so low that the blades are already below the surface. And the funny thing is that they think with the zoom camera, you can zoom around the curve and see also the bottom of the windmills, and this picture is already zoomed in, and this is their understanding. And the funny thing is about there is a camera, it's called P1000 from
Yeah,
Nikon, and they
the
discontinued
famous.
it. And it is just a camera it's one of these super zoom cameras. It doesn't have an exchangeable lens, tiny sensor, but it has 125 times magnification, so quite a lot for such a small thing. And Nikon discontinued it, and they have the rumor that that NASA did it, and so that nobody can zoom with this around the curve, because this camera would be capable to debunk the globe. And this is completely nonsense. I told them also you can buy affordable telescopes which have a higher magnification, and then you see it with your own eyes, not on a display via a sensor. And I thought you guys only trust your own eyes. And then they said, no, it's not the same, blah blah blah. They discontinued us because of NASA, and it's nonsense. Yeah.
Well, just hello to Nightwall. Thanks very much for showing up. Good to see you here. And obviously everyone else is popping in as they can. I'll try and keep an eye out for you. Lots going on here. I mean, as I'm sure you may be aware, both Austin Whitsitt and recently Flatsoid have made observations with their eyes and measurements with their eyes. Austin did it with the angle of the sun when he was in Antarctica, and Flatsoid recently did a degree angle southwest or southeast from his location by his eyes, saying it was 118 degrees. But we're not sure if he's actually got anywhere close to that. But there we go. So yes, it seems to be something to do with flat earthers seem to believe that they can measure things with their eyes rather than actual equipment, So this is a kind of prime example of that, where you have the flat earthers thinking that everything is flat, but actually in reality what you've shown here is it does show a curve. Now obviously your image is not to scale. That man is not 5 miles
and this
high
is
or
what
something.
the point. They asked me, and so he's now looking down, and we don't look down in reality. I did the math. I will show that in the end. And basically the angle he's looking down is 0.0419 degree. So it is 4,000 still of 1 degree. Is he looking downwards?
You're not going to be able to measure that with your eyes, are you?
Yeah. And the other thing is the mill. They said, okay, then the mill is leaning away from you. You are leaning in the other direction. And the angle between you and the windmill would be 0.08, so less than a 10th degree. So also not, you don't see it with your eyes, because of the scale.
You'd need something special to be able to measure that angle, wouldn't you? The actual angle, then that's the angle going away from you, isn't it? As you're looking at it. That isn't the same as the dip angle, though, is it?
No, this is something else. So we come to this later.
Yep, that's fine. I'm helping our flat Earth people who might watch this sort of follow along, because sometimes when you see streams and they go, it's not that because whatever, and they just say you're wrong, where I don't want to do that and you don't want to do that. We want to kind of like point out some actual facts, and these are all proven things. These are all done with calculations and proven, and we're explaining what you see in reality. Okay, so we are using pictures, obviously, but that's just demonstration, and these are all things that you can do yourself. With the right equipment.
Picture here on the upper right with the windmill, this here in the Netherlands, and everybody can go there and observe it.
Absolutely. So this is the classic one that I keep seeing on Facebook. Obviously, when people are saying it's flat, and most of the, shall we say, I don't like globe versus flat so much as deniers versus reality. And that's kind of why we sort of chose this stream to be called Welcome to Reality, because it's not about globe versus flat. It's more to do with denying versus reality, and this is something that you will see in reality. Now, this shows clearly why or how the Earth is curved and the effect that it has in reality, and it's not perspective. You know, we know about perspective. That's perspective. You know, that they're
this
saying
is
it all just the tram lines.
yeah, this is
Now, go on.
parallel lines
Yeah.
basically meet at their vanishing point, no?
Mhm.
And basically, as I said, you're looking down only 0.041 degrees, no? And basically, this is why you don't notice it, and why the horizon seems to be on our eye level, no? Because of scale. And they choose always photos with the chip on the horizon and claim, look, we can see it. But there are enough videos also, or GIF files, where you see a ship disappearing and they disappear bottom first, and then at least you see the upper part. No? This is quite obvious effect,
Yeah,
or the
and
result of. No.
that's something that's seen quite often, isn't it? And I'm sure if you've watched any sort of what they class as sort of like debunking videos where they actually show a large ship like actually going over the horizon, as opposed to the tiny little boats that haven't gone over the horizon
Yeah.
that people like Dave Weiss tends to push, and all the other main
I
flat Earth
posted
people,
once
or
a
deniers.
ship, a small. It was a sailing ship, a small one, and you could see it disappear. That it disappeared beyond the horizon or below the horizon, and they told me this ship is sinking or something.
Yeah, and it's like, where's the rest of the ship gone? Is it
This is
literally
sometimes
sinking? And then
hilarious.
do we need to call the Coast Guard before
Yeah.
we to go any further with this
Mm.
picture? Yeah. So this is the other one that you often see, and I'm
Mm.
sure a lot of the viewers here have seen. If not, it basically is highlighting rather clearly. I mean, obviously that is not a direct horizon, because when you get that close to any kind of ball, it's going to show up. That's on a
Yeah.
macro level, you know.
But
So it's going to
this,
show a macro, but it does show
and
that you can
this,
have a straight line off a
yeah,
sphere.
yeah, this is the size basically. When you're a bacteria on a basketball, the
Mhm.
basketball is flat for you, and it's basically the same to us. Now we are, let me say, I'm 1 meter 70. Earth's radius is what is this, 6,300 something kilometers. And the circumference is 40,000 kilometers. So we are a bacteria basically on the basketball.
Yeah, and this is something that deniers have a problem with, isn't it? It's the scale of the Earth, the actual full size of it. And I'm sure in later streams we can look at things like that in a bit more detail. I will point out, anyone watching, please stay on, because we have a lovely piece near the end where TechTranslate actually debunks the wonderful Shane Saint Plagier and
Yeah, yeah. Oh, yeah, this guy.
his terrible stuff that he's come out with. So we're lucky to have our co-host here today, Tech, is going to debunk that later for us. But in the meantime, let's move on and see what else we've got here. So this is a comparison that you made. Now, if you want to just explain that.
Yeah. So basically, I thought about it. How would the horizon look like on flat Earth? Now, on the left one is the real one, and when you are on a hypothetical flat Earth, your view goes basically to infinity. But there's the atmosphere, and the atmosphere scatters light, and this is called the Rayleigh scattering, even on a clear day. Now, the clear atmosphere scatters light. The evidence is our sky's blue. No, and this is one of the reasons, because this Rayleigh scattering scatters especially strongly the blue light, especially, and the red light not so much. And this is why the sky is blue, because the light is scattered to everywhere. And the same would basically limit our vision. Yeah, so basically the light which is coming from far away doesn't reach us because it is scattered by the light. So basically you would see always a blurry horizon.
Yep.
And of course the windmills would be much more up than on the picture on the left.
Yeah, because obviously on the left they're hidden behind the curve. On the right is an impression of what it would look like on a flat plane, as it were. Yeah. So this shows the reality, as you put it quite clearly. That's how it looks in reality, and that's the hypothetical flat Earth
On the
version,
bottom,
which would be the denying if you don't believe in the reality, of course.
yeah, okay. And in the bottom, basically, is this scheme within the line of sight and beyond of the line of sight. And on the right, basically, below beyond your sight would be below the bottom, and in the direction to the right, it would be limited in the end by the scattering of the atmosphere. The light scattering of the atmosphere.
So with like the hypothetical flat Earth, would it still have a limitation of vision because of light scattering?
You would not see until from the UK to USA because the light gets scattered too much.
But would I be able to see like places from the UK all the way over into mid-Europe, for example?
I'm not quite sure. I made one calculation. I'm not sure. This was about 1,000 kilometers, and
It's a long way.
1,000 kilometers, and you can't see anything anymore. It's much
Okay.
less. But it's a good idea for another slide. To calculate with the Rayleigh scattering how far you can see. This would be interesting. Yeah.
We can maybe look at that again for our future. And if anyone comes up with any suggestions for future episodes, please either, if you're here, leave it in the comments. We can have a look at it, or if you're not here, leave it in the comments and we'll look at it later. But let's have a look. So this is actually some of your calculations, and this is obviously based on Pythagoras.
Yeah, right.
Whatever your regional equivalent saying is, but yeah.
This is basically
calculations you were saying about,
Yeah, I posted this, but basically after the last one. So I made basically 3 slides, and this one I wanted to show that you can calculate it. This is pure geometrical. This is Pythagoras. And we are looking for the distance d. We have r. R is the radius of the Earth. We have h, how high we are. And you solve this equation for d and put in the values, you got this 4.65 kilometers.
So we got a statement there to say the bottom-up obstruction due to natural optics can be shown when making observations over flat surfaces. And is that what we were kind of saying before?
Yeah, of course. When you have things on the surface, this will obstruct your view. And this is why in this example we are looking basically on the sea. Because there we have obviously this obstruction. So it comes closer to a real sphere. So the Earth is, of course, not a complete 100% square. We have mountains. We have also the equator is a little bit thicker than at the poles. And so this is a theoretical horizon for the average radius of the Earth, pure geometrically.
Yeah. So this is all the math behind it, and I don't know how many people here are math orientated. I, for one, am not, but I do follow it. I'm knowledgeable enough to follow it. Yeah, not necessarily good enough to calculate it myself, because my math level is of the starter program, shall we say. But my objective of reality is following people like you who have done this, and obviously Pythagoras, who did it thousands of years ago. So is there a quick way of explaining this to maybe somebody who's a little bit unsure? Yep.
Yep.
Sorry.
Okay. Sorry. In the end, it is Pythagoras theorem where I wrote this, there I basically draw in this rectangle. This is triangle, right triangle with a with a 90-degree angle, and on the left is a square plus b square equals c square. This is basically Pythagoras. And then with the red arrow to the right, I show what I replace with this. So A becomes D. This is the distance to the horizon we want to know. Then B becomes R, and C becomes R plus H. Now this is and then in the equation we solve for D. Now it's to the power of 2. This is why we have to use the square root at this place. Now. And then we put in the values. This can everybody do with a calculator. Hello. And
just say hello to Irons in order quickly. Thanks very much for showing up. Great to see you here. I hope we're doing something that's fairly enjoyable. We're literally just going over some math stuff, explaining the horizon and how it can be calculated on a sphere. So that's good. Thanks very much for being here. So this is looming of the
foreground blocks, the backgrounds. Sorry, my English is a bit rusty. Looming for the backgrounds, for the foreground.
Looming of the foreground.
Yeah. Okay.
Yeah.
Okay.
So that's just another explanation, I guess. And so Zerzu's come back again. He got sidetracked. So hello to you, and welcome back. I hope you don't get sidetracked again. So
okay.
So obviously this is sort of the basic triangle here of the Pythagoras theorem, and it's kind of like illustrated here to show. And then obviously these are all kind of like the basic calculations of Pythagoras to calculate off a radius. Yeah. So is that a tangent off a radius? Is that right?
Of D, basically, yes.
Yeah.
So where R is the horizon, with the R arrow goes straight up is the horizon, basically. And I got here beaten up by these flat earthers because they said no, okay. Again, the leaning to the right and the left, where I made the calculation, it's just between him and the windmill. If they have the same distance from the horizon, it would be just 0.08 degrees, so not noticeable because of the size of the Earth. And the other thing was then they came with refraction of the atmosphere, and this was also why I made the next slide, part 3.
So just for everyone, like in case you didn't spot at the top there, this is the geometrically without the
this is
atmosphere
without
refraction.
any optical effects. No? And in the next slide, it is this I took from Wikipedia. It is basically explained. We have in the atmosphere a density gradient. The atmosphere is denser to the bottom because of gravity, and also molecules have a certain weight, and the pressure is higher. Now, so it becomes also optical more dense, and it is and light always bends towards the optical dense medium. This is when you have a prism, it goes also down into the optical dense medium, and because the gradient is continuously. Now this is not like air and glass. No, it becomes slowly denser and denser. And this is why the light from the sun, so the sun on the actual position, is where it is in reality, and it is already below the horizon. But the light still reaches our eyes, no? But our eyes, or rather our brain, interpret everything which comes into our eyes that it must be also in this direction. No?
So I'm also right in saying, I'm also right in saying that the refraction level actually gets greater over water and cold. Is that right?
Yeah, the colder, there are also other. When it's very cold, the stronger this gradient is, the stronger is also the refraction. But you can also have other interesting effects like mirages and so on, when you have dense air and then warm air or opposite. And we come to this later on with the picture of the sun. But here,
Yes.
the thing is, you see basically, or your brain thinks the sun is the upper one, perceived shape of and position of the sun. No? And in reality, it's
this works the same with like when you see those laser tests as well that some
Yeah.
flat earthers have done. This is basically what's happening, isn't it? Over long distances across water at night where it may be colder. This is literally what happens and why it isn't flat. It's actually still curved, because the actual position as demonstrated in this is actually curved down. And obviously, if anyone knows about laser pointers or lasers, they actually spread outwards in a cone very similar to your image here, but in the opposite direction to the sun there. So the actual bit that you see as on the other side of that curve would be that actual spreading out of that, going through the layers of air and the optical density. And then obviously with that atmospheric refraction, you'd still be able to see it a long distance away over the side of a lake. But that doesn't mean the lake is flat. It means that this is being applied to the visualization of seeing that laser across the lake. And that's the reality as opposed to the denialism, isn't it?
And there was also the flat earthers carried out an experiment on a frozen lake with a laser. And they could see it very far away. And the reason is a frozen lake is the worst place to make measurements. Yeah, you have very cold air over the surface of the lake. No? And the other thing is, you don't know exactly if the ice is really level. Yeah, there are sometimes winds when the ice form. Yeah, the wind goes in one direction, then even this one might not be completely level. No? And so this was a bad thing. But there was another experiment. It's also on YouTube, where flat earthers spent a good amount of money to make an experiment with a laser, and they found out the Earth is not flat.
Yeah,
It's quite enjoyable.
Yeah, and I you're right. It is enjoyable to obviously see when. I don't like to sort of gloat in their failures, like some people might, that's just not me. I tend to joke about it a little bit in chats and comments in Facebook posts and stuff, but I don't tend to insult anyone, because I don't believe that's how you kind of learn, personally, and I don't think that actually helps with people's education. So I think it's good to sort of have a little bit of a joke, but not necessarily at their expense, as it were, because sometimes these people don't understand it. I come into this a number of years back, actually watching people a bit like Zozu Zyquin here in chat, who's done stuff on flat earthers before, and I kind of like looked at it openly. I obviously had my own background of believing in a globe. That's what I was taught, but obviously to look at everything objectively. And it's only now, these years later, that the arguments that they have put forward don't actually add up when you put it against reality. There's observed reality, but as we've just highlighted with this demonstration and with atmospheric refraction and lasers across lakes, whether they're frozen or otherwise, the reality is there is a curve there. And that's kind of where I yeah, you're right, there is some humor in seeing them fail, but only if they learn from it. If they don't, then
this is the problem. Yeah, this is they believe only in what feeds their narrative, and everything else is fake. This is really frustrating sometimes. And you have also there are different fluffs. Now, I had already with a few, I think 2 or 3, quite let me say honest discussion where they asked questions. I answered them, and one also, he stopped replying, but he gave me a like. So I thought, okay, maybe he thinks now about it.
Yeah.
And the other thing are, you have very often these very religious fundamentalists, basically, who say it's not written in the Bible explicitly that the earth is a sphere, so it can't be. And they are very dogmatic, and it's impossible to find arguments which they would accept.
Yeah,
Because
the
everything,
denialism of it
yeah,
all, isn't it?
yeah.
Yeah. It looks like
Okay.
Zerzu's looking for somebody to who's got a car by the sounds of things, because he also wants a video driving to the tower. He needs to find someone in, is that Trail County supposed to be, North Dakota? Would be neat to get an image of the KRDX TV mast from about 20 miles out. Not sure exactly how high that mast is, but it sounds like it's pretty darn high and probably on a very large mountain somewhere. So if you want to take Zerzu in a car to Dakota, there you go. There's an offer for you.
Okay. Yeah, I think on the next slide we see how far we can see with. This is the one you see very often in meme. The Chicago skyline from 50 kilometers away from the Indiana Dunes. I looked this up on Google Earth where it is, and I measured it. It's 52 kilometers basically. But if you, unfortunately, the picture is very small on the top. And down below, I have a close-up of the skyline, and you really see that a part is already hidden.
Yeah.
And in this one, I used basically, it starts also. It's not a geometrical it is a geometrical calculation, but it uses an adaptation for refraction. And this is I linked also with this post the homepage of him and Andrew T. Young, and he explains basically how to calculate the refraction, and then he comes to so for average temperature, average atmospheric conditions, basically in his assumption he uses the radius r slash, and the radius r slash is 7/6 multiplied by r, so a larger radius of the Earth basically, and this fits very good. Compensates basically for the refraction, because the refraction, what does it? It follows a little bit the curve, and therefore you can see farther than pure geometrically. And this this assumption, or no, not assumption, the simplification basically makes the radius by a certain factor bigger, and this matches most atmospheric conditions.
So making the R value larger, you're actually flattening out the radius, aren't you?
Yeah,
So,
exactly.
So you're actually giving the advantage to the denier, if you like, by saying it's actually flatter. In reality, it's actually even more curved, and yet we're still seeing this Chicago skyline with part of the skyline completely missing, which as we've demonstrated earlier with the other slides and your interpretation of the windmills, you would actually be able to see it on a flat plane. And it kind of, whenever you see this and they're saying we shouldn't be able to see it on a globe, this calculation actually shows that it's perfectly easy to do on a globe. And it's even showing you which part is not going to be visible because of the globe, but also highlighting the bit that is visible, which is the bit that actually is the observation. In the very top picture is the bit that you can see, and the bottom picture is illustrating obviously the bit that is not visible because of the curve. And Andrew T. Young's obviously explained all that in his link, but it's one of those things that seem to be used quite a bit, the Chicago skyline, because obviously it's done on a specific day with refraction and things like this that are involved, that basically gives that impression that you can see further than an Earth calculator might tell you. But what we find in reality is there's lots of actual detailed explanations for these things, and things that actually, if you actually open up the denialism and put it to one side for a moment, you can actually learn how these things are possible, and you don't have to revert to having a flat plane or something.
And what is also important, you see here, I took the height 3 meter. Now, this is because the photos were taken basically on the dune. And when you see at the beach, it slopes always upwards, no? And the person is maybe 170 tall, no? And 1.3 meter adds very fast, no? And here I made also here on a slide which I have on the right, when you are at 1.7 meter height, no, then your horizon would be 5 kilometers away with refraction. No, if you are 3 meters high, it's already 6.6 kilometers away. No, at 5 kilometer, already 8.6. Yeah, and at 10 meter height, it's already 12.19 away. No, and so it's really dependent on how high you are standing, and they are standing on it's called Indiana Dunes, so they are not basically at 1.70 meters on the ground. No.
Now, this has been explained many a time in Facebook posts, and I'm sure on X, in chat. But and I've seen it in other people's videos and streams even. But it's nice to actually see it in a calculated method like that. You know, I don't necessarily understand, or I follow the maths. You know, I wouldn't necessarily be able to write the maths, if that makes sense. So it's good to see this, and obviously we're showing again that you can take a tangent of a sphere in your demonstration there using the R values. So yeah, I think with all of these long distance shots, they're all done on specific days. I'm sure in Andrew T. Young's description, it gives more details about that as well. And this is reality. You know, it can be done. It's perfectly explainable on a spherical globe. So this is what you were saying before, isn't it, about the sunset? Now, this is our friend Brock Riddick. I believe this one was actually off
This
X
is
post, wasn't it?
maybe for the audience who are not so into the flat Earth model. On flat Earth, of course, the sun cannot go below the horizon. According to them, it goes only far away and becomes therefore smaller and smaller. And they show very often this kind of pictures where it looks like this, but you see here clearly how distorted it is. Now, you see here on the upper right already as if there is a rip through the sun. No? And this can happen on conditions where you have maybe warmer air, maybe it was a hot day or a hot season, the water is quite warm, and you have maybe colder air above. No? So basically on the lower parts, the view goes again upwards towards the sky, and this is why you can basically see through the sun. No?
And this is a little bit how like mirages work.
Yeah. Basically, this is exactly this is how mirages work. These are also by heat. You have this sometimes on the street. Now, when the street is very hot in summer, it looks like water, and the cars from the other side are reflected inside. This is basically a hot air mirage. No, the hot air mirage basically bends the light upwards again. No, and there are also cold air mirages where it bends downwards again, and then you have very interesting effects sometimes on the sea. You see sometimes a double horizon, the real horizon, and basically also a second one. No? I've laid a picture of this. This looks quite interesting. These are some effects you have.
And this is another. this is another sort of opportunity in a way to sort of show that sometimes when you're looking at these things or posts from people, whether it's Brock or anyone else, and they're trying to explain that this is what it would look like on a flat Earth, and that's their version of reality. But actually, when you apply the other factors, it's not just the optical what you see across the water there. When you actually apply the refraction and the mirage, the optical mirage, whatever you want to call it, there are reality explanations, and in reality that is a perfectly nice one of them.
Yeah, I think I replied with this picture and said, when you want to disprove a flat Earth, please do it on a clear day without too much atmospheric distortions. No? And this is, I saw it already like this. No? So when the conditions are right, you see clearly the sun is setting below the horizon. It's not becoming smaller and smaller. And there are also pictures in the net when you compare the size of the sun. When it's going down to the horizon, it's exactly at the same size. It goes exactly at the same size down. No?
Yeah, I mean, obviously that I believe he was referring to the previous slide there. That one looks for Catsoid, as he's more well known these days, or is it for Catsoid from Donkia? I'm not entirely certain, but you need to watch Thursday's stream to find out exactly what Flatsoid has been up to in Flatsoid's perspective. I think just quickly on that, I like I say, I don't kind of like really tend to insult people, but I think Flatsoid, with his recent sort of trying to find fakery in the final experiment, has basically lost all his credibility in my mind anyway. And possibly he'll find it difficult to recover from jumping in too quickly, and maybe you should look at some of these explanations that you've done on X that kind of highlight the reality of things rather than sort of the denialism and sort of just not wanting to accept it, because that's the reality. That sun isn't going away anywhere. It's not moving away from us. It's just going behind the horizon because the Earth is rotating.
Yeah,
the
exactly.
sun. It does always confuse people a little bit when people, for example, with the final experiment, they're saying the sun circles them around for 24 hours. Technically, it doesn't. It's the Earth that's rotating. But it obviously just is a matter that it appears that way from that person's
this is
perspective.
basically the same when you're in a train and you, from your perspective, it looks like if the railway station is going away, but in reality you are moving. So inertia, it's basically one of the laws of Newton. Inertia, every object keeps basically its direction in which it is moving. And if you are in this frame of reference, you don't feel anything. So if you are moving with it, you think you're not moving. And but you see when you have reference points like the sun, it appears as if the sun is moving. This is
exactly. So and this is just something that all this stuff today is fairly basic. There are calculations and math behind it, which tech has wonderfully done for everyone. So you don't have to kind of stress your brain. You can look at all this while having a coffee and not kind of worry about it too much because it's all done for you. Now, I always believe that people who have got to an academic level should be believed. Now, whether or not they're believed entirely is another thing altogether, because obviously you can have opposing views. But everything we've discussed today is agreed upon. This is the reality of it, where it's actually agreed upon that this is the way that the Earth works. And unless you can sort of disprove that, and I don't mean with just a meme or we see too far or something along those lines, or there's no curve on the horizon. We've already explained that the peripheral vision that you see here on this sun picture is very narrow. You know, you're not going to see a peripheral curve on any picture that is so narrow and minute. But it's worth stepping back a little bit sometimes and just taking in a breath and accepting that there's people out there who are a lot smarter than you. And I guarantee even the smart people say the same things. You know, they probably feel the same way, that they probably feel a bit stupid in whatever particular field they're looking at and think there's going to be smarter people than me. Now, the difference is that I don't go around saying to people, you're wrong, unless I can back it up with evidence from people who have already reviewed all this.
Yeah.
Now, and people, just going back to flat soil, for example, who might just throw out accusations to say it's fake, there must be something wrong with it, I don't like this, it feels uncomfortable, something's not right here. That isn't an argument, you know, and anyone who comes to the table with that kind of argument can basically just step down, in my opinion. If you can come back and say, actually, this part of science is completely wrong and I can prove it with peer-reviewed studies that have been accepted throughout the world, then you might have a point and a Nobel Prize coming your way, you know. But until then, I think we need to stick with reality, you know, and I'm sure
That's
you'd
better.
agree with that.
Yeah. Okay.
So this is the wonderful thing that we've been building up to today. This is kind of like your highlight of today, which is
this is a post of Shane. I just, it took me more than half an hour to understand what he wants to do. Yeah. And in the end, he says, basically his conclusion is, we can only see as far as the horizon. Yeah, basically our eyes are not capable to see farther than the horizon. And his basic evidence, in quotation mark, may I share my screen? I can show it a little bit bigger and point. I can zoom in. It's okay.
Of course. Let me just do some bits and pieces. I'll take this one down for you. Yeah,
okay. Bildschirmteilen.
This is our wonderful TechTranslate and his lovely face. You can tell the difference between me and him because I'm the one with the accent. So
yeah, I'm from Germany. I think this is quite obvious.
There we go.
Okay.
There we go.
We've got that, there we go. Okay.
You've shared
I think
everything. I'm sure you can work that out.
Shane, and he made a very long post. Okay, his post. 1 second.
Now, if anyone doesn't know Shane St. Plaisir, he makes a lot of claims, mainly that he can have a flat Earth model that replicates the globe, but he did actually use Earth radius, a spherical radius, and calculations from, is it Walter Bisden, wasn't it? He stole some of the code for that. That's well known, and the actual code is viewable.
This was his entire post. Now, don't worry, I don't going to read this. It was really tough to read this because to find out in which direction he wants to go, he tries to trick. Even he managed 2 times to trick me, and putting me on the wrong path, basically. No? But in the end, he's saying the following. He calculated, this is the so-called Rayleigh criterion. This Rayleigh criterion basically tells you the angle, the minimum or the minimum angle we can distinguish 2 different points. In other words, it means if something is far away at a certain distance, this angle becomes smaller. Now, here you see this angle is quite big. It's the same size, but here it becomes smaller. So apparently also the object becomes smaller. And this criterion basically tells the angle when our eyes cannot distinguish between the upper point and the lower point. So basically it will appear as 1 point. And his argumentation is that basically he makes the calculation and comes to this value. And then he calculates with the horizon formula this value and says it's the same. So his argument is we can only see as far as our eyes can see, and this is exactly as long as the horizon. Yeah. So and I looked at this a little bit. The formulas regarding calculating this Rayleigh criterion and the maximum distance these objects can be separated, or we can still see it as larger than point, is correct. He puts in, so his math is right, but he puts in specific values here. 666. I got this very late. This is,
They love that
they
number,
claim
don't
this
they?
is evil. No? So it works only for 666 nanometers, which is red light. About
just quickly, I'll say something that one thing that I've noticed since kind of like following this whole sort of two-sided thing with flat Earth and globe, or deniers and reality, as I like to put it. The 666. I'll just rewind a minute and start again. It would appear that they use that number way more than any glober does. Any reality person, you know. And I think I'm going to go and just call them reality deniers, and then the realities. But that they use that number way more than anything I've ever seen posted by anyone trying to explain something that happens in reality. So I kind of wonder whether their motives are a little bit driven by that number more than
it's possible,
reality, you know? But sorry, you were saying about that equates to the redshift.
So basically he had a typo, but he used the right formula. So, but he puts in specific values, so the 666 nanometers, and for the diameter, this is basically the opening of our pupil, no? But in reality, it can range from 2 millimeter to 8 millimeter. And he puts in a specific value, and then he uses the observer height, 1.8 meters. And this would mean basically the diffraction limit of human vision is independent how tall we are. So somebody who's 1.50 meter can see things at the same distance as somebody who is higher. Okay, his horizon would be maybe a little bit different, but theoretically, in a straight line, he could see as in the same length. And the other thing is here, if you put in, for example, it works only for red light. If you put in green light, blue light, violet light, you get complete different values. And so his one works only for red light. And then he claims this number is in the horizon calculation, 1 to 2. And it's also 1 to 2 in this calculation. And he said this is clearly evidence that horizon and diffraction limit are the same. And I went through this optical part. I'm not the optical guy. I had really to go into the subject, and it took some time until I understood everything. And then I was too tired to look at this, and I said, oh shit, now he's messing up with the horizon. I did not really look at it, and I thought maybe he made a good trick to smuggle in this 1.22. But the next day I looked at this and I did not trust my eyes, because this is not the same. This is 2.44 divided by 2. And this would imply basically 2 is equal to 244 divided by 2. And this is obviously then 1 to 2 and multiplied by 2. And these are not equal signs. And I put in the values for the first one. This is the correct. This is.
Do you think this is put in there on purpose then by him, just to try and mislead
this is
people?
Completely on purpose, and he puts it in very late. So basically, when you're already tired, like me, you don't look at this anymore.
Yeah, and apologies for anyone trying to follow this.
This is basically what he tries to do. And I put in the values here for this. this is this Näherung. This is basically a simplification of the geometrical horizon formula. No,
Okay.
this works very fine because our height is very small in comparison to the horizon, but it is a simplification. No, but this works quite nice. And then I put in the same values here. Then you get this one, and when you put in this here, you get this one. So this is definitely not the same when you have this number inside, and this is what he claims. No, so
Yeah.
basically,
So
I put in.
it sort of highlights really that he's like you say,
Yeah.
waited quite a long way into that before he
Mm.
slipped in something that someone like me wouldn't necessarily know, you know,
Yeah. Yep.
and would potentially read
And
this and
honestly, I did not see it at this first sight. I nearly posted it. I thought this was equal. I did not see the two here because I did not see it, and this was why in my original post here is for all two equations I wrote. No,
yeah.
and I corrected it then and made the third one in, and but then I realized, oh shit, there's another two. This is also not the same. No, okay, and basically conclusions for the geometrical horizon and the maximum diffraction limit are generally not the same. The number 1 to 2 appears only in the Rayleigh criterion and not in the horizon formula. And we can resolve details beyond 4,700 meters under these conditions. Objects larger than 1.8 meters. And for 1.8 meters objects, it works with all colors except red for pupil opening of 2.6 millimeters. So it works only with a specific value. And when I went through this was I chatted here with you, Jonas. I got really mad at him because this clearly shows he's not a flat earther. He knows exactly what he's doing, because in order to do this calculation, you have to work backwards from here. You have to take this and this value, put it here in, and solve for and tweak the others so that you get this result. With Excel,
Yeah.
it's quite easy, and you adjust a little bit the values, and then you get these numbers. But he put, obviously, you see here also his post was very long. He put a lot of work in this, and this is basically what we also discussed. And I think he likes basically to fool people in an evil way. Otherwise, I cannot describe it differently, because when you can do this calculation and also backwards, you know exactly what you're doing, and you cannot fool anybody with this. No?
And that's something
And
that people need to be aware of, isn't it?
yeah,
That sometimes when you look at something, whether it's from Shane or somebody else,
mm,
it's actually worth not just taking it at face value. And
mm,
you've demonstrated quite clearly there that this is misleading on
yeah,
purpose.
yeah, yeah,
And the chances are, like as you say, that in order to get this far in what
mm,
Shane's presented, he knows that the globe
yeah,
is there, is real. That's the reality.
mm,
And he's
yeah,
used his position to try and sway people who may not be as let's
mm,
just say as focused as yourself, who would be able to look at this and debunk it, basically,
yeah,
you know. And it's not my favorite term, but it's obviously something that you've done here and highlighted where he is purposefully misled in
mm,
order to make a conclusion that will bolster a side, shall we say.
mm. And here the file name's chain 3. This was his third slide. AH stands for asshole. So
Well,
I had to put it in so here. Chain's garbage. This
just for the record,
suppose.
Tech does
Yeah,
not
yeah,
like
yeah,
Shane. Okay.
yeah, yeah. Because this is really what he does. And the other thing is, I had a discussion with him regarding he presents a flat Earth model working. How is it called? It's in JavaScript. So basically, it shows the flat Earth and which areas are in light and which not. No, and of course, this does not work this way. Sun is not a spotlight. And in winter times, it does not work that you have light around the south, but not on the North Pole. And in his model, it works like this. And the thing is, he stole this model from somebody who made this to debunk flat Earth. Yeah, and this code is how's it called? Public domain. And he took it and used it for his purpose. No? And I had a conversation with him. I'm not going to show everything, but wait 1 second. I should have opened
careful
this
what you're opening.
before. Yeah.
It's like Martin has got some.
This. Yeah, here this was one which I showed you already. I went through the code of Walter Bissing, who made this model, no? And I found here also in the calculation the distance, the average distance of the sun. No, this is nearly 150 million kilometers, and this number. And I confronted Jane with this, and I said, basically, wait, okay, this was another slide, but I confronted him with this, and then he made a mistake. He forwarded to me a few links where he exactly addresses that this number is in his code. No?
Yeah.
And then he makes an excuse why he put it in. No? And I responded to this and I said, it's completely BS. Yeah. Why, when you have flat Earth model where your sun is only 400 to 600 kilometer away, no, 1,000 kilometer away, why do you use this large distance to normalize a vector? It makes absolutely no sense. No, and to this he did not answer anymore. No, and before he made also wait, I chain.
You got yourself a whole little Shane document there, which is.
I did not post regarding this because I want to make it. I have to do a little bit more research and.
Okay, I just want to address this going on in chat just quickly.
Okay, I don't find it right now, but he wrote basically why he put in the distance of the sun and said he took an arbitrary value basically to normalize the vector. Yeah, but exactly this number. This is completely garbage. So this shows clearly that he's using the heliocentric model to calculate the shadow, and then he makes a projection. This is the azimuthal projection, which looks like basically like a disk, and projected it on this. No, this is basically, that's Shane, and okay.
And why you don't like him so much?
Because it's clear that he knows what he's doing, and he likes to deceive people. This is his hobby, maybe. And this is really a worse person. This is all I can say. Now here, a few pictures regarding refraction. Here you see in the denser medium, this is glass. No? It goes in, it goes down. And the interesting part is this one. Light speed, see, we know that it's always the same. Yeah, but this is only for light speed in a vacuum. If you go in an optical denser medium, the light speed is lower. No? And you can have even electrons, for example, nuclear reactors, which are moderated with water. You have a blue light. These are electrons which move faster than light in water. Yep. In water, it is possible, but not in the vacuum. No? Because C is basically, we say that it's the speed of light, but in reality, it's the speed of causality. No information can propagate faster than C in every medium. No? And light in vacuum has the same speed. No? But in other medium, it is slower. No? And here, it's basically the explanation. Here it is faster. This is basically each thing represents one of the wave. It hits here the glass. From here it propagates slowly. But here it hits it first. And this is the reason. And here later why this front has basically to stay the same. Now, this is not breaking up in this way, and because it is slower in light, in water or whatever, in glass, it bends basically down. No, and this is basically the explanation. Here, you're faster. You hit this here, and then because your light is slower here, you get basically this angle. No? Otherwise, if it would be the same speed, it would be straight. No? And this is basically the explanation why you have this here. And it depends on the density of optical density of the medium. If it's more denser in diamonds, for example, it's much higher. No?
Yeah,
And yeah,
this is why I have Tech here, you see, because he understands all this stuff perfectly, you know, and someone like me can sit here a little bit in awe and kind of like understand that I've seen a straw bending water. You know, we did that at school when we were kids and learnt about refractions and things like that. But
Mm,
this is the reality of the world that we live in, isn't it? And
yeah.
sometimes it's good to have this sort of explanation on a little bit more of a in-depth way of looking at it, because it does obviously stay on topic with how the horizon works and what we view on the horizon, and
Mm,
how you've got those cold air
mm.
mirages and obviously hot air mirages.
Yeah. And this is also the reason when you put a spoon or something in a clear in a glass of clear water, it looks like bent upwards. No? And this is also the
Mhm.
reason the light from here goes up and is refracted now in this direction, and we see it. No? And because our brain can only interpret that this comes from a straight line, it basically shows us that it's coming from here.
Yeah,
No?
our eyes and our brain is
Yeah.
very limited in a lot of ways, and that's obviously
Yeah.
why it's always worth doing further investigations and using the correct tools. And
Mm,
what we're doing here is highlighting
mm,
the reality of how the world works for
yeah.
us as human beings who live on this earth, um, and it sort of shows that there's a lot of factors involved. You know, what we
Mm,
sometimes see with deniers is that they're using a specific example with sort of one explanation involved, where we
mm,
actually see in reality lots of different things working together, which
mm,
cause what we actually see optically.
mm,
You know, so it's very interesting to sort of like have all this. I don't know whether anyone
mm,
in chat's got any questions. I see
mm.
that like Martin has been having a little
Yeah, yeah.
chat there with Z, which
And
is good.
here are these mirages. You remember the sunlight. This was a similar effect like this, a cold air mirage. You have cold air, here you have another temperature, and then you have hot air. No? And you see here basically, you can see then the boat sometimes more than one time. And I don't know what this here is, but I think it's just the water far away. And you see basically three horizons here. You
Mm,
see basically three horizons. And this is on special occasion, you can see this. And the other thing I think everybody saw already, on hot days, the street basically looks as if there's water and reflecting. This is because you have hot air here and cool air. And then basically the light goes here. And I know, sorry, yeah, from the object to the observer. So
yep.
you think basically that it's a mirror. No?
Yeah,
Yeah.
absolutely. Yeah, I fully understand that. I mean, obviously, refraction is well known by the human race. We use it with glasses all the time. I see because
Mm,
refraction exists, you know, and we understand it fully, and it's something that can't be ignored.
mm,
And so when I see posts in Facebook or YouTube comments on things, and they're sort of saying that like you're going to say it's refraction, that's because refraction is part of reality. You
yeah,
know,
yeah.
it exists, whether it's the 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 hot mirage or the cold mirage or just the bending of light through the atmosphere, or whether it's just temperature conditions, or whether you've got a longer distance because it's got those perfect conditions where it's all
Mm,
kind of working in your favor. You know, there could be somebody else a few 100 miles away with slightly different conditions who can't see what you can see in that particular location on that particular day. So it's this dishonesty of denial where they're picking and choosing particular things is what upsets me the most, I think, because it's denying the rest of reality. It's saying in these particular situations I can make it work to my favor. That's misrepresenting the reality that we live in. You know,
Yeah, this is true. Yeah.
it's picking and choosing rather than actually accepting that there's multiple factors that can be involved at any one time and multiple things that can explain a particular phenomenon.
Yeah, and also here the picture which you showed in the beginning, where basically the vanishing point was the horizon when you're standing on the ground. When you're on an airplane, you know, and you have here parallel lines, they don't meet at the horizon higher. No? So, and this is basically your eye level. They meet at eye level, no? And you clearly see the horizon is here's the horizon.
It's
Oh,
never
this
rises
no.
to eye level, does it?
And
It
but
can't.
it's in the sky is the vanishing point apparently, and this is a clear, even if it looks flat here. No, okay, you have here also small mountains, so it's not visual possible to see it anyway. But if you connect here the lines of these parallel streets, you land up here in the sky. And this clearly shows on flat Earth the horizon would be still here.
Yes, because it would just carry on regardless. But this is a visual debunking of like the horizon rising to eye level, because it can't. You know, there's no way that the horizon beneath your feet can raise to your eyes. You know, because if it's rising to eye level, then the ground that your feet are on would continue going forwards and then have to go up 6 meters, 6 feet, or whatever, however tall you are, you know. So, and that doesn't happen in reality in the same way that, like, obviously with train tracks, they never actually touch each other. It just looks as if they're going to go off and converge, but they never do because they're the same distance apart all the way up the track. Otherwise, the train would fall off, you know. So it's pretty straightforward.
And the other thing is here, their argument, this may be what we can do also, here with the ship here, with the platform, where they
the famous black swan,
this is that it is below the horizon, and they claim, also there are other photos where they claim it is not possible, and this is definitely photographed from a ship. No? And if you take a picture from a ship, I found here, it was very difficult to find the height of a ship, the length and everything, how much they can carry very easy. But here in Wikipedia in Germany, I found
they're all a bit different.
So basically, the site is 30 meter high. Now, okay, and basically, if you go 30 meters high, your horizon is already 21 kilometer. 21 kilometer away. No, and when you're standing on the surface with my height, you can only see 5 kilometer away. So with refraction, no. And you see, this is a complete different distance. This is the reason why you can see much farther. You see the impact basically, what it does. No?
That's brilliant.
And the other thing is here, where I calculated, because I said he's leaning away, and here I basically make the calculation, and in the end it is between him. Okay, I did not draw here this in between him and this one. It would be 0.08 degree. This is
which obviously is not leaning away in the way that is demonstrated
so it's
in the picture.
not noticeable. No,
Yeah.
And then very often the question comes, also, in which angle does he have to look down? No? And if you calculate this, you come to 0.0419. So this is your perception is you're looking straight. Yeah,
And this is
there's
what I
the
love. This
horizon.
is what I love about your work, Tech, is that you're not just showing a meme or an illustration. You actually have the calculations that back that up,
Mm,
and show the math behind it, and show the reality that it is
mm,
such a small, insignificant amount that your eyes
mm.
are not going to detect
Yeah,
those
and here,
numbers.
yeah, and here also, what they very often ask, how much does it curve? No? And here you see 1 kilometer. This is basically the same variables which I use here, and it goes down. Oh, okay, I have also the equations here, and so basically per kilometer, the Earth curves down by 0.07 meters, which is 7.8 centimeters. No? And so it is barely noticeable. And you see when I put in here what is it? When I put here this 1.7 meters, no, this is,
Now, is
this
this stuff
mm,
all on your X post as well, or is this just
yeah,
stuff
yeah.
that you have? So this
No,
is
this
all.
is, I made this for today. It's just to
Ah,
show, no?
so this is
And
something that you will put on your
yeah,
X post maybe to sort of show,
yeah.
or maybe we can link it somehow so that
Yeah,
people
yeah.
can
I think
look
I
at it.
will post this later on, and when I go 5.4.5 kilometers, and you see on this you go 1 meter 50 down now on
Mm,
4.5 kilometers. And then here you see the impact. It's not a linear because the Earth goes not in a straight way down, but here more and more. So the more kilometer kick in, and if you take the same here, the distance from the horizon which we had, it was about this one. So we come basically to a similar value. I think it was 1.6 kilometer away. Yeah, you see, you come nearly to this value. No?
that's
And
brilliant. So we've
this
been.
is basically the same. No? And here you see they ask what is the angle it curves down. It is 0.0090 meter per kilometer. So basically, if you're 1 kilometer away, this angle between you and this point, 1 kilometer away, is just 0.0090. So basically nothing, which you cannot see. But if you make the calculation, you come to a circumference of 40,000 kilometers, which matches perfectly the Earth.
So there you go. Welcome to reality, everyone.
Yeah.
As demonstrated by TechTranslate. Do we have anything more on the horizon? Has anyone got any questions in chat? Thank you very much for sticking at it for this long. I know we've been going through it. It probably seems like a lecture in some ways, but actually this is the reality that we live in. And sometimes we need to highlight the reality side of it. And although it may be a little bit, I wouldn't say boring. Boring is the wrong
Mm,
word, isn't it? For some people, it can be a little bit heavy. Should we say that? Do you think that's fair?
mm,
You know, it can be a lot of work to take in. So we've been at that for an hour. Hopefully, we've answered any questions and explained the horizon today. That was the
mm.
idea. Obviously, we've come with the evidence behind that and the calculations that show that, and some brief explanations about some of the things that you will see optically with refraction, mirages, and whether that's sort of hot and cold temperatures. If anyone has any ideas of what you'd like to see in our next stream, obviously put that in the comments section. We can have a look at that together, and me and Tech can work out
Yeah,
what
we
to do
can
next.
maybe the moon landing, or why the rotation of the Earth does not make the water of the oceans fly away. This is also quite interesting.
Maybe, yeah.
Yeah,
All very good suggestions. I mean, moon landings, I think, probably a
yeah,
later
moon
date.
landing.
You know, we've only
Mm,
just started with the horizon. Let's not go straight from Earth to the moon. I
yeah,
think that might confuse people even more. But we
yeah.
can definitely look at other things that we see on Earth and other
Mm,
things that we experience on Earth. Um, Obviously, there's big ones like gravity. Um, don't say it doesn't exist because it does. It's not a
this
theory
would be
like I've
also a
got an idea.
quite interesting subject for one day. Yeah,
Yeah,
yeah.
it's an actual scientific theory, and if you actually know what that means, then you'll realize that it's actually a thing rather than just an idea. If you don't know what a scientific theory is, then please look that up. We haven't got time today to go into the differences between a idea theory and a scientific theory.
Mm.
But thank you so much. This has been absolutely great. Thank you everyone in chat. We've had
and down below is my handle on X. If you want,
please.
You will find me under this handle.
Plug yourself. Plug. What do you do on X? This is basically what you do on X, isn't it?
Yeah. Basically, you can find all the slides which we show with also a bit more in-depth explanations. If you go on X and look at this, and if you follow and like my posts, I would be happy.
Please do, please. And obviously, if you'd like what you've seen today here, then please subscribe to NOPEGENX as well. Obviously, we want to try and make this as regular as we possibly can. Both Tech and myself work for a living, so this is this is going to be as regular as we can make it. And in the meantime, I'll try and get out as many other videos for everyone to enjoy about the other side, the things that people are doing wrong or saying wrong, the deniers, the ones that don't accept reality yet. Luckily, obviously, following the Fano experiment, I say luckily, but I think it was going to happen anyway. Following the Fano experiment, Jaren obviously questioned a lot of things and has stated he's no longer a flat Earth believer. He has his other beliefs, of course. He's not completely satisfied himself yet, and that's what this is about. It's about satisfying yourself. And obviously, what we're doing today is showing you one part of reality. There's a lot of parts to reality. Now, I did see earlier that our dear friend was talking about space. Is it Martin Callie? Thank you very much for being here. I'm sure I may have misinterpreted some of your messages, but it seems like you have questions, which is good, But we'll leave today with something that I picked up from the ISS, seeing as you brought it up. A lovely shot of the horizon from the ISS. As I leave, I'll say thank you very much for being here, Tech. It's been an absolute pleasure. Thank you for all your knowledge and your understanding of reality, way better than mine, and for helping me learn more in detail, shall we say. Some of the math does go over my head. I'm not that, but that's good. That's why we have mathematicians, and people who understand this stuff. So thank you very much for that. If you want more of these streams, obviously let us know, and we can sort something out. But in the meantime, here's some ISS footage, and we will see you next time. Please hit the like button on the globe. On the globe. Welcome to reality.
Welcome to reality.